Good morning. Thanks for coming today. This talk is about var, local variable type inference in Java. My name is Stuart Marks. I work at Oracle on OpenJDK on the core libraries team. I work on collections, Lambda streams, and occasionally things like deprecation, and occasionally make forays into language stuff like the var feature. Twitter is a good way to keep in touch with me. This is my Twitter handle here, @StuartMarks. I've created a hashtag for this talk, #varwithstyle. I won't be able to monitor Twitter during the talk. However, afterwards, I will take a look at this, and if you have any questions that I haven't answered in the talk, please tweet on that hashtag, and I'll take a look at it and try to answer it later. Okay, the official name is Local Variable Type Inference, and so it's pretty descriptive. Local variable means that it applies to local variables only. And type inference means that the Java compiler infers the type for you instead of you having to declare the type explicitly. It's pretty simple. Let me show you some examples here. All right. Most variable declarations in Java have an explicit type. So suppose we have a class customer. We're declaring a variable named customer, and we're initializing it with a call to the constructor, new customer. The var declaration in place of the explicit type declaration asks the compiler to infer the type. So we can say var customer equals new customer instead of customer equals new customer. Now, this is a very important point. Many of you already know this, but there are a lot of questions about this. Java is still statically typed. The use of var does not fundamentally change the type system of Java. Still statically typed. Unlike JavaScript, which also has something called var, Java still has a static type system. So the two lines of code above are essentially equivalent. The only thing is that at compile time, the compiler sees var, infers the type to be customer, and it's almost exactly as if you had written customer, the explicit class name, instead of var. So there's really not that much going on here. So type inference is not new to Java. It has appeared already in various forms in different language features. One of them is lambdas. It's very easy to write a lambda expression without declaring any explicit types for the lambda parameters. Those, in fact, are also inferred. There are a few other cases in Java, for instance, the diamond operator, where type inference is done. So type inference, sometimes you read an article that says that type inference is, Java now has type inference. Well, in fact, it has already appeared in various different places in different language features. I think this is the first time that there's been a new feature and what looks like a new keyword that's been introduced to deal with type inference. So for that reason, it's attracted a lot of attention. Okay, where can var be used? Now, it's local variable type inference, so local variables only. So those are variables that are declared within a method. There are a few other places. Inside of a method that are considered local variables. In particular, a useful place is as the resource variable in a try with resources statement. Another good place for the use of var is the loop variable in a for each loop. Now, it turns out there are a bunch of places where var cannot be used. Can't be used for method parameters, can't be used for method return types, and it can't be used for fields. Why not? Well, in fact, it's possible for the compiler to do some type inference, and in principle, it would be possible for the compiler to do some type inference and infer the types, for instance, the types of a field or the types of the return type of a method. But part of the design is that we decided not to do that. The reason is that things like things like class fields, method parameters, and method return types are part of the class's API, and those are written into the class file. And we felt that it would better to be explicit when declaring those. If the types were inferred, it would be pretty easy to modify the code within a method and accidentally change the type that was inferred. And without noticing, actually change a method's signature. So that could lead to source compatibility problems or binary compatibility problems if you have classes that have already been compiled against the old version of the class. So we decided to keep type inference out of things that are essentially out of method signatures, and also with fields, because fields, while most fields are not visible outside the class, quite often, well, you could have public static fields, and if those types were inferred, those are visible outside the class. But quite often, people use reflection to get at the types of, to get at field values. And if field types were inferred, then that might give rise to difficult problems where you'd only notice that in reflective code when it happened at runtime. So anyway, we decided to restrict type inference using var to local variables. All right, how does var infer the type? So when you declare a local variable using var, you must have an initializer on the right-hand side. And furthermore, that initializer must have a well-defined or well-understood type. So, and then the type of the initializer on the right-hand side of the equal sign, that is used as the type that is inferred for the variable. So let's run through a few quick examples here. Var customer equals new customer. So we have a class customer, and we call its constructor, and that returns an object of type customer. So that's what the variable is initialized with, so that's what the type is inferred with. Pretty simple. Var name equals Terry. All right, so that's a string literal. It has a type, Java-lang string. And so that's the type that's inferred for the variable name. Var numbers equals list of 1, 2, 3. This is a little bit wrinkle here. Those numbers, those values are auto-boxed into capital integer, and list.of returns a list of whatever types of arguments it's been given. So the return type is list of integer, and that's the type that's inferred for the variable named numbers. Pretty simple. Okay, there are a bunch of places where var doesn't work. Var customer, semicolon. There's no initializer. It's a compile time error. Var customer equals null. Now, earlier I said the initializer has to have a well-defined type. And so null, what's the type of null? Well, there's a bunch of type system voodoo in the language spec. There's actually a null type, which you cannot write, and it's the subtype of all types. Okay. But that's really not important. The point is that there's no specific type that null has. So what should be the type that's inferred for this, this variable? Well, it could be object. I mean, that would work. We could say, we could have a special rule that said, if we initialize something to null and in a var declaration, then its type is inferred to be object. We could do that, but that's probably wrong, because if you declare a variable and initialize it to null, you're probably going to assign something else to it. And when you assign something else to it, and then maybe return that or assign that further on, object is probably not what you want. So trying to infer the type of some variable that's been initialized to null is not really going to get us very far. So we decided to disallow it. Okay, and this last line is attempting to initialize a variable with a lambda expression. So with lambda expressions, lambdas don't have, you can't look at a lambda in isolation and determine what its type is. It needs to have its type determined by the target type, which comes from the surrounding context. And so in this case, if the surrounding context is var, you want to have the lambda expression trying to infer the type from its surrounding context, like the type declaration, and then you have var that says, okay, well, I'm going to infer the type from what's over here. And so now we have this circularity going on. So there simply is not enough type information to do any inference in this case. So that's a compile time error. All right, if you declare a variable using var, can that be reassigned? Yes. So var name equals Terry. That's a string. We talked about that before. Then later on in the method, we reassign name to be Dana. That's fine. Dana is also a string. Then, later on, we assign name to be list of Robin and Kim. Now that's an error because that's a different type. List of Robin and Kim is a list of string. And list of string is not compatible with string. So there's no magic going on here where there's some kind of unification or global analysis of what the type is. In a var declaration, the type is inferred from the initializer, and that's the end of story. If it can't be done, it's a compile time error. If it can be done, the name variable is inferred to have type of string. And then so thereafter, everything else is type checked against that. And then again, var namelist equals list.of Robin and Kim. So in that case, this is kind of starting a new example here. List of string is the type that's inferred for namelist. And then later on, we can reassign namelist to another array list because the array list is a subtype of list. Okay, now what if you want a variable that can't be reassigned? Well, in typical Java fashion, we just declare that final. There was a bunch of discussion about using alternative keywords such as let or val for this, and there, for a variety of reasons we cited against that. It turns out it sounds like it would be useful, but if you actually look at it very carefully, it's not. So anyway, I'll take questions at the end. I'll take questions at the end, please.
Okay, sorry.
Anyway, so if you want a variable that can't be reassigned, then just declare it to be final. All right, so let's run through a few simple examples here. We have a method create customer that returns customer, and then we declare a local variable customer equals new customer. Pretty easy. Try buffered reader equals new files.new buffered reader. And then we do a for each loop over some orders and return customer. So let's replace the explicit type declarations with var. So we're using var for the customer variable, var for the reader in the resource, and var for the for loop variable. Okay, that's pretty much it. Thanks for coming. So no, it wouldn't be. There's something about introducing Java language features, especially fairly simple ones, that generates a bunch of controversy. So when we first proposed this, people started writing articles about it, describing it, and never read the comments. So the problem is, I have this compulsion, you go read the comments, and people say, Oracle's ruining Java. It's a stupid feature. Oh, this is going to ruin the programming language. This is terrible because Java is being turned into JavaScript. People will write bad programs using var. And so after a while, you begin to see the same criticisms over and over. And so that actually is what the point of this talk is, to respond to the constructive parts of these criticisms. So part of it is, I think there's some clear misunderstandings. Like I said before, var does not change the static nature of the Java type system. So Java is not being turned into JavaScript. If you want to program in JavaScript, please program in JavaScript. But we're not fundamentally changing anything about Java. And people like the static type system, we're not changing that. So that's simply a misunderstanding. If you look through these criticisms, I think there is a grain of truth underneath there, which is people are worried about if var is misused, then yeah, maybe it can result in code that is worse than it was before. Now, is that going to be the end of the world? No, but I think that's a valid concern. So what we should do instead of saying var is a bad feature or never use var, let's talk about when we should use var and when we shouldn't. All right, so let's talk about the benefits of using var. So the reason that we add features to the programming language is that we want to enable developers to write better code. Nobody intentionally adds a feature that enables people to write worse code. Now, you can take all the existing features or any new ones and write bad code. That's true. And so what we do want to do is say, how can you use var to make your code better? So one thing it does is it reduces verbosity and it reduces clutter. But one thing that I think people don't quite realize is they're very used to explicit type declarations in Java. And that's nice because whenever you see a variable, you say, what's going on with this variable? What's its type? And you go look at the type declaration, and it's always there. But sometimes for some variables, in some contexts, the type information isn't that important. There are other things about the code that uses that variable that's more important. And in those cases, if you can replace the explicit type declaration with var, the code actually gets better. One thing that can do is you can let the variable's name stand out. Sometimes the types will overwhelm things. Sometimes the types are redundant. Sometimes they just add a lot of clutter and they overwhelm the code and you can't actually see what's going on. I'll have some very vivid examples of this later on. So if you replace those explicit types with var, then code gets better. One thing that it does is it enables easier refactoring. Sometimes you have a complicated expression. You might want to extract that out and give it a variable with a nice name. Oh, but boy, if the type for this is really complicated, maybe I'm not going to do that, so I'll just leave it in line. Well, if you use var for that, then the type won't get in the way, and you can do that extraction and make your code better. So really, the issue is one of readability. If you've written code using var, and if you use var well, then your code should get more readable. That's the main principle here. It's not the amount of keyboarding that one needs to do. So one of the other criticisms of var is, we don't need var, I can just use autocomplete. Well, so that means that you have fewer keystrokes because your IDE will help you with that. And that's nice, but that text ends up being in your source code, and everybody who looks at that source code has to understand that. And if the explicit type declaration is not that important, they have to read past that and see what's going on. So again, it's readability code, not the amount of keyboarding or typing on the keyboard that you need to do. All right, so should you use var always? When should you use it? When shouldn't you use it? So there's this criticism, which is people will write bad code using var. Yes, they will. If we didn't have var, they would still be writing bad code. So really, the problem is, if there are people out there writing bad code, let's work together so that people write less bad code. We're not going to say, let's avoid adding a feature because people are going to write bad code with it. I think there are other ways we can deal with people who write bad code. So anyway, there's this fundamental question, though, which is when's the right time to use var and when isn't? So what I've done is I've written a document called the Style Guidelines for the use of var, or Local Variable Type Inference Style Guidelines. So in that document, I lay out a number of examples of certainly some principles for how we are evaluating code, and also some examples of good uses and misuses of var. All right, so this is published on the OpenJDK website. Don't worry, I will post the URL at the end so you can all see it. The outline of this document is, there are 4 principles, and these really transcend var, I think, but these have never really been written down. But basically, these are expanding on what I said a moment ago about readability. And so really, again, it's readability, it's not the amount of keyboarding you need to do. Also, principles like you should be able to look at the code and figure out what's going on without searching through the whole file. Now, the compiler can certainly do that because it has a global notion of what's going on in your program. But when you are reading a piece of code on the screen, you should write the code so that the reader of that code, who might be you 6 months from now, will be able to understand it just by looking at the local context without having to search around through the whole file. Anyway, given those principles, we go through several different guidelines for how to use var and how not to use var. So I'm not going to go through all of these. There's a lot of detail, and sometimes there's some weird corner cases. So I'm not going to go through this exhaustively, but I will touch on several of these in the remainder of the talk. All right. So again, back to the comments in the on various articles about things. One of the criticisms that is often leveled against var in Java is people will create a strawman example, and they'll say, okay, suppose I have some code, my class x equals get something. Well, if we use var in that case, then we no longer know that x is of type my class. We have to go hunt around and find the declaration of get something to do that. So, I mean, you can't, this is unreadable code. Oracle should never have added the var feature. And the problem with these examples is that they're really stupid examples. They're not actually dealing with real code, right? So if we say var x, what does x mean? That's a name. You can give names to variables, and names can have meanings. And so this example doesn't do that. The example says get something. Well, what's something? Is something a free variable for some, it's going to be replaced by some real type name in some actual code? Well, probably. Sometimes people do write methods with the actual name get something, I suppose. But anyway, if you have code like this, I mean, I don't think anybody actually has code like this. So this kind of example is not suitable for evaluating the use of var. So let's use a better one, and I think a more realistic one. Input stream equals socket.getInputStream. Everybody knows what this does, right? Socket, okay, what type is that? It's probably a JavaNet socket. You can get the input stream out of it and assign it to a variable named input stream. Let's replace the declaration of input stream with var. Have we lost anything by saying input stream only 2 times instead of 3 times? No. So anyway, so now we can bring in the guidelines here. So if you look at guideline G1, it says choose variable names that provide useful information. So if you have a variable named input stream and you read things from it, well, it's pretty clear that it's an input stream. So maybe the explicit type declaration of capital input stream isn't doing us very much good in this context. And then another point is if you look at the initializer of the variable, that also gives you a lot of information. I'm saying socket.getInputStream. Well, what does that do? That gets an input stream out of the socket, right? Do I need an explicit type declaration input stream to tell me that? Not really. All right, so let's look at a bigger example here. Let's kind of absorb this example for a while. This is actually one try with resources statement that has 3 resource variables. And look at that for a while and see if you can see where the variables are. We're getting a socket, or so we're getting an input stream out of a socket, and then we're wrapping it in an input stream reader, and then wrapping that in a buffered reader, and then we're doing something inside the body of the try block. All right, so where are the variables? Okay, so on this slide, I've highlighted the variable names. And notice how they're sort of buried in the middle of things because, just because of the long type names in the java.io package. Actually, quick aside here, some people say, oh, well, you don't need variable names. You should just use the nesting approach. With try with resources, we prefer to have separate resource variables because if there's an error opening an inner one, we want the try with resources statement to be able to close the outer ones correctly if there's an error. In any case, so given that we have this pattern, we want to declare 3 resource variables. And here it's really kind of messy. The type names are pretty long, and so they add clutter. And also they make the lines long so that you have to put line breaks in the middle of your resource variable declarations. And then that makes the try block really kind of cumbersome. So let's look what happens when we replace this with var. Okay, so var, they all line up here, all the variable names line up, and it's like, oh, this is nice. We open an input stream reader, and a buffered reader. Oh, okay, I can see what's going on now. All right, let's take another example. So you might have a class named provider, and so you want to get a new one of them. So you say provider equals new provider. Well, what's a provider? Is it a crypto algorithm provider, or is it a provider of something else? Well, in the particular context where I discussed this code with a colleague, it's actually a provider of a repository hosting service. So maybe we should call that. I mean, provider is not a very good name for that because it's far too general. So we'd like to have more specific. We'd like to have a more specific name for that service that he's implemented. So let's call that repository hosting provider. Okay, so now if we want to create one of those, we say repository hosting provider equals new repository. All right. Well, and so what happens there is that if you're a library author and you choose a long descriptive variable name, and it might be necessary because, I mean, provider is too general. A hosting provider, that might not be specific enough either, because you might have a variety of services being hosted. So really, repository hosting provider is a reasonably specific name for what this is. But if you choose a name like that, then it penalizes everybody who has to use it, because that's how they need to declare their variables. But if we have var, you can just say var provider equals new repository hosting provider. Oh, I know exactly what that is. And I'm just going to name my variable provider and then use it, because the context I'm in, well, I can look at what the declaration is, but in the context I'm in, I know I'm dealing with repository hosting, so that's fine. So what var allows you to do as a library author is choose better names for your classes, because you're not penalizing the users of your classes having to write redundant declarations for the variable and also have the same name appear on the constructor. Okay, generics. Ooh. All right, here is an example where here's some library code, and I'm tempted to apologize for the wildcards, but it is what it is. But the fact is, when you're writing library code, you really do need to use wildcards in your method signature, and this tends to infect all the variables in your method implementation, and that's a fact of life. There's a whole other discussion to be had about variants in generics, but I'm not going to get into that here. But anyway, this is a typical method in a generic class where we want to, well, it's a typical method that uses generic methods. So we put the wildcards in. And in this case, the idea is let's remove some matching entries from a map up to a maximum number. And it's a little bit contrived, but there it is. This is sort of derived from real code. I'm kind of renamed all the cases and stuff, but this kind of thing actually does happen. So in this case, we need to iterate over the map, but we need to use the explicit iterator form because we're going to be removing things from the map. And so what we need to do is grab an iterator over the map's entry set and then write a conventional for loop as opposed to a for each for loop. And then get the next entry out of there and then do something with it. Okay, can you see, okay, so in the conventional for loop, there's the initializer declaration, there is the termination condition, and then there's the increment. Can you see where these are in this code? All right, so I've highlighted them. That code highlighted in color is the initialization portion of the conventional for loop. And then the termination condition is right there. That little thing has next off to the side. And then it turns out there's no increment in this for loop because we actually do it inside the loop body. And so we do it here where we declare a local variable to take the next, get the next item out of the iterator. So you can see there are big opportunities here because we have these horrible wildcarded declarations. And so let's see what happens when we replace those declarations with var. So a lot of cleanups happen here, but really the exact type of that iterator with the nested wildcards are required. And so writing out the explicit type, here I'll go back and show that. The nested wildcards of that iterator variable really make it complicated. And in fact, you don't really care what the exact type is. You know you have a map from string to number, and you're iterating over the entries, so you're dealing with strings and numbers. That's what this code does. It's pretty easy to understand. So writing out the exact type of this iterator is a burden. So just write var. And then it's the same thing with a map entry. Just say var entry equals iterator.next. So in cases like this, the statement has been made. Well, Java is great because it always requires explicit types, and programmers need to know explicit types everywhere. That's not true. And in the cases where it's not true is when you should use var. Okay, so there's a little bit of a wrinkle here. Moving on, there's a notion of programming to the interface in Java, and var does affect this a little bit. So this is a little bit subtle. This is something you never find on the internet, which is why you come to conferences. You can have a subtle discussion with some nuances in it, and this is one of those. And so programming to the interface is still very important. But I don't think you need to worry about it too much with local variables. So let's see what's going on here. So first of all, with var, well, OK, so a typical declaration is list of string names equals new array list, diamond, initial name. So we have some initial name somewhere. It's presumably something like a list of strings. And so that's a typical declaration. We have some names, local variable, and its type is explicitly declared as list of strings. Now, replace that with var. So we say var names equals new array list. What happens here is that the type of the names variable is inferred from what's on the right-hand side. And the type of what's on the right-hand side is array list of string instead of list of string. Oh, horrifying, you're not programming to the interface anymore. Well, is this really a problem? All right, so let's look at this in a little bit more context, right? So, and this is, again, one of these problems with discussions about var is that there's never any discussion of context. So here, if we add some context to this, let's say this is a method that takes a list of initial names, it creates some local variable with a temporary list, does some stuff with it, and then returns it. Okay? Pretty simple. So what happens if we change the declaration of the local variable to use var instead? So names now has type array list of string instead of list of string. I don't think this makes a difference. If you look at the code, it's adding some things to the list. It calls add, add all. All of those things are on array list as well as list. The fact is, the difference in the API between array list and list is hardly anything. Yeah, there are a couple methods. You might use one accidentally, but if it's a short method, it's not really going to be a problem. But notice, the method returns list of string. And this is really where programming to the interface comes in. When you're talking about method signatures, you don't want to bind to the implementation. So in this case, sure, inside the method, we used var, and it was inferred to have a type, which is the implementation type. But when we return it, the implementation type disappeared. And so we're returning a list of string. And that's where programming to the interface is important. When you are moving objects between different pieces of code, you have types declared in method parameters and method return types and so forth. That's where you pay attention to programming to the interface. Sometimes maybe it's a little bit important inside of a method, but in a lot of places it's not. And when it's not important to have the exact interface type, just go ahead and use var. Oh, and notice, like I said before, we can't use var or type inference for method parameters, method return types, right? For kind of the same reason, actually. We want to be explicit about the types of method signatures. OK, there's some subtleties going on with var when it's used with the diamond operator and generic methods. Guideline 6 in the style guide covers that. So there's several things going on here. You have to we'll set up a few rules and then show an example. But with var, the variable's type is inferred from the initializer. So the initializer has to have a well-defined type. Now, if the initializer also uses diamond, diamond also uses type inference, and that needs to get its type information from somewhere. It might get type information from its constructor arguments, but it also might get type information from the left-hand side. And so, like I said before, there's might be some circularities going on with the type inference. And if you are unaware of this problem, you might get unexpected results. So let's take a look at some example code here. So I've declared 4 variables, v1, v2, v3, and v4. And then there's also, just for setup, there's a list of string initial names. OK, so v1 is a typical variable declaration, list of string, v1 equals new array list, diamond with initial names. So the diamond operator gets its type information from a variety of places, including the argument. So the argument to the constructor is list of string. And so in order to match things up, the type that has to go in the diamond is string. And, well, that's OK. So the right-hand side is array list of string, and that's assigned to a variable of list of string. So that works. There's no change there. I mean, that's the way things always, that's the way things have been in Java since Java 5. Oh, sorry, Java 7, when the diamond operator was introduced. OK, now let's use var on the left-hand side. So we say new array list diamond initial names. So again, the same sort of analysis goes on. Where does the diamond operator get its type information? So initial names has enough type information there. It's a list of string, and so new array list with diamond gets new array list of string. OK, and then that's the type of the initializer. So v2 is inferred to have that type. And again, this is what I just talked about. In this case, it is array list of string instead of list of string. And in many contexts, that's just OK. All right, now let's look at v3. Again, going back to an explicit type, we say new array list diamond with no arguments. And so that's OK. In this case, the diamond syntax gets its type information from the left-hand side. It says, I'm being called in a case where this is being assigned to a list of string, and so what matches there in the diamond is string. And so that's the way this works. And so v3, of course, it's explicitly declared to have list of string. But that's why this works. Now, on line 4, we say var v4 equals new array list diamond. Now here, diamond gives up because it doesn't have enough information. It looks at the constructor arguments, and there aren't any. It looks at the left-hand side. From your point of view, it looks at the left-hand side of the declaration, and there's no information there. And so what diamond does is it says, well, I don't have any constraints on this, so this must be object. And so the right-hand side initializer becomes array list of object, and then v4 becomes array list of object. And this is probably not what you want. So in cases like this, you have to be careful of using var with the initializer using the diamond in a case where there isn't enough information, or using a generic method, which I don't show here, but it's basically the same thing going on. If the initializer is a generic method, you have to make sure that there's enough type information available for the diamond operator or for the generic method to infer the intended type. So, but is this a big deal? If you're not sure what the issue is, or something funny is going on in your code because you get some compiler error that says, oh, you can't do this because you can't cast object to list or something like that, OK, just don't use var in this case. And that's OK. All right, I'm going to switch over to demonstration here. How are we doing? OK, looks like that's big enough. All right, so this is, I just wanted to find some sample code somewhere. So I went to internet tutorial website and found some sample code that does some JSON processing. What this actually does is not really very important at all, but it just has a mixture of interesting types and code and so forth. So let's go through this and see where we can use var. All right, so where are some, OK, so there are no fields in this class, but there's a method parameter here. Can't use var there by rule. Local variable here, root JSON. Can't use it here because there's no initializer. All right, how about here? We have try with resources. We can go ahead and change that to var. A couple of resource variables here. And so that's nice. There's a local variable declaration here. We can change that to use var. Oh, actually, and then so this is, this is NetBeans 9. And so the version numbering is out of sync. So NetBeans 9 actually supports Java 10. And so we can use the refactoring here to change, replace explicit type with var. Very good. OK, so some more code here. JSON array, do the same thing. We have now here we get websites out of the array, and that's an array of string. We can actually use it there. Notice that the initializers here on the right-hand side are providing enough type information, so we can replace that with var. We have a for loop that indexes over JSON values in the JSON array. Make sure I'm hitting the right, whoops, wrong one there. Oh, actually, NetBeans bugs. Sven, I need to talk to you about this. Okay, so there's that means refactoring doesn't work in some cases, so I had to just type that there. But basically, you go back to local variables and replace that with var, and you can do it here as well. So I went through and replaced them all. Is that the right thing? I mean, it doesn't make that much of a difference. It does clean up the try with resources block a little bit. But I think, so those are the places where it's possible to use var. What are the places where it is appropriate or advantageous to use var? And so with this kind of JSON API, there are a bunch of different types in that API, like JSON object, JSON array, and so forth, that actually don't tell you anything about what's going on in the application, right? So if you have a list of addresses, that's you store that in. If you have an array of addresses in your JSON object, you might have a variable whose type is JSON array. Well, JSON array of what, right? So there, it's a place where you might consider using the name of, or actually it's not addresses, but it's websites. So the fact that this variable's type, actually, let's see what the type is here. You hold down a shift key and it says the type of this is JSON array. So that's not telling you anything. So having the explicit type there is really not very helpful at all. More reasonable is to say, let's choose a better name for this variable. So yeah, it's a JSON array, but it's JSON array of what, right? So that's a good example of where you might want to use var but choose a better name. But here, this is an array of strings, and so actually that's pretty significant if we're going to be doing string processing. So maybe what we should do is in this case, we can do the inverse refactoring and replace var with the explicit type, and that might be a perfectly fine thing to do. There's no rule that says you have to use var everywhere. So one thing that is interesting is that if you go through and use var, it turns out that there are some yellow warning lines under here. There are a bunch of names that you needed to import just to declare variables whose actual types weren't all that interesting, so we replaced them with var. And so we can even clean up our imports. And IDEs manage your imports for you, but it just reduces the amount of bulk in the file that you have to skip past or look at if you want to adjust the imports. So overall, I think there's not all that much going on here. You can use var in a bunch of different places in real code, but I think the point is use var where it makes sense to use var, and if it doesn't make sense to use var in some cases, don't use it. All right, back to the presentation. All right, so going to summarize here. var tells the compiler to infer the variable's type for you instead of requiring you to declare it explicitly. And so again, over decades of Java programming, we've gotten very used to having explicit types everywhere. And the thing to realize here is that having explicit types everywhere is not always necessary for the understanding of the programmer, of the reader of your programs. If var is used judiciously, it can improve the readability of your code, improve the clarity, and it can reduce clutter and verbosity. It's not always obvious when you should and should not use var, and so we've written a style guide for that, and I will show you the links to that on the next slide. So there are actually several documents here. So I put QR codes for the links to those documents. There's the style guide is the one on top. Just a week or two, a few weeks ago, we published an FAQ. That's the second QR code there. If you like, you can look at JEP 286 that has a technical introduction to the var proposal. And you can contact me on Twitter at Stuart Marks or on the hashtag #VarWithStyle. And today only, at 7 o'clock, Simon Ritter and I are doing a BOF called VAR, Threat or Menace. I hope to see you there. Thank you. So we have a few minutes for questions. Is there a question anybody have? Yeah, so Mario's been waiting patiently.
Well, it is about one of the slides at the beginning, the one when you show the final bar, I guess. was around slide number 6 or something like this.
I mean, there's not much going on. It's basically just final var. Oh, there it is. Yeah.
In the list example, if you switch the two lines, it will not compile anymore, right? I mean, if you say var name list equals to new array list, and you reassign the name list to the list of Robin and Kim, it will not compile anymore. Is that correct?
Yes. Okay. So let me repeat the question. I think your understanding is correct. Okay. So in the second example here, we have var namelist equals list of Rob and Kim, and then we reassign namelist to array list. And so that works because in the second line, array list is a subtype of list. Oh, sorry. So in the first line, list.of, that actually returns the type list of string. No implementation type, just the interface. And so when you assign the implementation class to that, that is a compatible assignment. Now the question was, what happens if you swap this? If you say var names list equals new array list, and then maybe you put in enough information there to make sure that it gets to be array list of string, and then you reassign it later on to list of Rob and Kim. That will cause an error because the variable now has the implementation type, and you are trying to assign a super type to a subtype. So yes, your intuition was correct on that. More questions? Yes, gentleman, right here. Do we need the keyword var? Well, okay, a little bit of background. So var is not a keyword in the typical sense like while or class. It can actually still be used in other contexts. So you can actually have a variable named var. So strictly speaking, var is a reserved type name. So you cannot have a class whose name is lowercase var. So if you have code that uses the symbol var in other places, then that should still continue to work unless you have a class named lowercase var. And since the very strong naming convention for Java is to use uppercase names for classes, we think that is a very small incompatibility. Now, I think there's another part to your question, which is, do we need to introduce a syntax for doing this, and maybe not have have var as something at all? Maybe just omit the type. And so, I think the problem is that it just doesn't, there isn't room in the grammar for being able to parse local variable declarations without some kind of type being there. Now, in Lambda expressions introduced a whole new area of syntax, and so you can just put the variable name there, and based on the context, the fact that there's an arrow later on means that the things to the left of the arrow of a Lambda expression are variable names. And so that's why we could get away without introducing something like var for Lambda expressions. But for local variables, there are too many things going on in the grammar inside of method context, so that if you need to introduce a local variable, there has to be something there. There has to be a production in the grammar that says, well, this is a type declaration of some form, whether it's an explicit type or whether it's var. So there needed to be a point in the grammar for that to be done, because if we just omitted that, I think that would just do too much damage to the grammar of the language. Okay, we got time for one more question. This gentleman right here. Yes, you.
You have said that the usage of var with purely generic on the right with the diamond operator is dangerous. Can the compiler warn us on such usage?
Okay, so the question was about using var with diamond operator, and can the compiler issue a warning for that? That's a good question. I don't think it does right now. I don't think the compiler issues a warning right now, and I think the example I showed was a bit of a pitfall. Probably, if you use var with diamond and there's not enough information to infer the right type, you're going to get object there, and that is quite likely to cause a compiler error downstream. It might be nice to have a warning at the point of declaration, because that is a case that is a little odd. It is not illegal to do that, but we have a class of warnings in the compiler called what we call lint warnings, which is legal code that is probably doing the wrong thing. So that's a good point. I think we will we'll take a look at that. And I see one of our compiler guys nodding there, so I might have a conversation with him afterwards. All right, out of time now. Thanks for your interest and attention. Enjoy the conference.